Hey guys, this is Megan from OnlineMathCircle AIME video tutorials, and today we're going to look at 2007 AIME II Problem number 1. A mathematical organization is producing a set of commemorative license plates. Each plate contains a sequence of 5 characters chosen from the 4 letters in AIME and the 4 digits in 2007. No character may appear in the sequence more times than it appears among the 4 letters in AIME or the 4 digits in 2007. A set of plates in which each possible sequence appears exactly once contains n license plates. Find n, divide by 10. So this problem can be easily approachable by using some casework. So we see here that no character may appear in the sequence more than it appears among the 4 letters in AIME, or the 4 digits in 2007. Basically what that means is that we cannot have any letters repeating, or any digits besides for 0 repeating, and 0 can only be used up to 2 times. So that means we cannot have a 5-character sequence with 5 letters or 5 digits. So these kinds of sequences are a no-no. So the only kinds of cases that we can have are 1 letter and 4 digits, 2 letters and 3 digits, 3 letters and 2 digits, or 4 letters and 1 digit. So let's look at each of the cases separately. Let's start with case 1 with 1 letter and 4 digits. So we have 4 possible letters, A, I, M, and E. So there are 4 ways that we can choose 1 letter. And seeing how we must have 4 digits in this case, we must use all 4 of the digits, 2, 0, 0, 7. So we must find the number of ways that we can permute a letter and a 2, a 0, a 0, and a 7. That makes a total of 5 objects. However, there are 2 duplicate objects. So we have to divide by 2 factorial in order to account for the indistinguishable permutations. So that gives us a total of 5 factorial divided by 2 factorial times 4, because of the way that we can have 4 possible outcomes for the letter, which is 120 over 2 times 4, or 60 times 4, or 240 license plates in this case. Now let's look at case 2 with 2 letters and 3 digits. So we need to find the number of ways that we can pick 2 letters from 4. So there are a total of 6 ways to do that. And to pick 3 digits, we can have 2, 7, and 0, or 0, 0, 2, or 0, 0, 7. So basically, what we have here is that for each of these combinations of digits that we can choose, we would have 2 distinct letters and 3 distinct digits in this first case. So that gives us a total of 5 objects to permute. So that can be done in 5 factorial ways. Then we have to multiply by 6 to account for the number of ways we can choose 2 letters. So we have 6 times 5 factorial, which is 6 times 120, which is 720 cases in this situation with 2, 7, and 0 as the digits. Now what if we have 0, 0, and 2? Well, we have 5 objects again, but this time we have to divide by 2 factorial to account for the 2 zeros that are indistinguishable. So we have 6 times 5 factorial divided by 2, which is 6 times 60, or 360. Similarly, 007, again, we have 2 zeros here, so it's the same as the previous case. 6 times 5 factorial divided by 2, which is 6 times 60, giving us 360. So our case with 2 letters and 3 digits has a total of 720 plus 360 plus 360, which is 1,440 license plates total for this case. Now let's move on to case 3 with 3 letters and 2 digits. So here we must choose 3 letters out of 4. There are 4 choose 3, or 4 ways to do this. And in order to pick 2 digits, we can have 2 and 7, 0 and 0, 0 and 2, or 0 and 7. So in each situation, we have 5 objects to permute. And in the first situation with a 2, 7, and 3 different letters, we basically have 5 factorial ways to permute them because all of the objects are distinct. And we have 4 ways to choose the 3 letters. So we have 4 times 5 factorial, which is 480 plates in this case. Now, if we have 0, 0, and 3 distinct letters, then we would have 4 times 5 factorial divided by 2 because of the 4 ways to choose 3 letters plus the 2 identical zeros. So in this case, we have 4 times 60, which is 240 plates in this case. Then for this, for 0, 2, again, we have 2 distinct digits and 3 distinct letters, so 5 distinct objects, so 4 times 5 factorial, 480. And then with 0 and 7, that's the same as the previous case, so that's also 480. And adding all of these up, gives us a total of 720 plus 960, which is 1,680 plates for case 3. Now let's move on to our final case, case 4, with 4 letters and 1 digit. So if we have 4 letters and 1 digit, obviously we have to use all 4 letters. So there's only one way to do this. But if we want to do 4 letters and 1 digit, then each of those cases will all have 5 distinct objects to permute because of 4 different letters plus and a digit. And that digit can be either a 2, 0, or 7. So then that means that gives us a total of 3 times 5 factorial, or 360 possible license plates in this situation. And since big N represents the total number of license plates that the whole set can make, we would have N equal to 240 plus 1,440 plus 1,680 plus 360. Adding all of these up, we get 1,800 plus 1920, which gives us 3,720. And divided by 10 would just be 3,720 divided by 10, which gives us a final answer of 372.